Hello, everyone. Nice to meet you. We're group 7, and I'm going to be taking you through our graph, the project. Yeah, and it's about explainable graph neural networks for heart disease detection. I am Kavma Hamza, and my colleagues are Namuto Sidan and Kalemal. So, a brief overview of our project. It's about creating models that predict heart disease and make out predictions. Our computational problems are individualized risk prediction, insight extraction from healthcare data, explainable graph neural networks for heart disease detection. So with the machine learning approach, we use deep learning, which has been there before, but then we maximize graph neural networks in healthcare applications. They're effective tools. They're widely used to model relationships between the data and aid predicting tasks. So we're going to be constructing graphs in most of our models for patient data. We train the models, for example, in GCN and GAN. Then we compare the GNN-based models with traditional machine learning methods like KNN and random forest, and RGNN were better. So the dataset and dataset preprocessing, we use that dataset, which is a compilation of 5 prominent heart disease datasets. It has 12 features, and here is the link below. The dataset consists of 12 features with a target variable indicating the presence and absence of heart disease. Contains 190 instances, and after removing duplicates, it had 918 unique patient records. Then this is a table showing the sample data in the data set. We have age, sex, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, maximum heart rate, exercising old peak, ST slope, and target. So the methods we used artificial neural networks, GCA, we used graph convolutional network, graph attention network, graph sage, KNN, random forest, linear regression, naive Bayes, SVM, and decision tree. These are the ADA sites. For example, this is a bar plot of sex distribution. Then this is a heat map of feature correlations. So these are the findings whereby we're comparing the models using accuracy, precision, recall, true positive, true negative, and the F1 score. So we have ANN, GCN, and the other models. We're comparing the accuracy, the precision, and the recall. So the insights, we found random forest with our best model with a highest accuracy of 94.54. And then that was the worst with the accuracy of 52.42 and precision of 51.9. The model selection, we chose GCN because captures dependencies and interaction between patients, and during evaluation, GCN demonstrated competitive performance across multiple metrics. So the limitations, we have data conversion and model explainability. We have dataset, our dataset had some few characteristics which are not good. Then our feature works, we have enhancing model accuracy, model explainability, utilizing more relational data, and enhancing its predictive capabilities. In conclusion, the study explores the use of GCN models for disease prediction, comparing them with traditional machine learning. This suggests GCNs could enhance medical diagnostics, particularly for disease detection. The future research should focus on refining model accuracy and ethical considerations.
Hello, this is Kalema Alan, and I'm going to take you through the code. So as my colleague has been talking about the dataset and the models we created, so in the code, we mounted our dataset as usual to the cloud, and here we're accessing it. These are the necessary requirements we're importing, and we carried out an EDA on the dataset. Here we're analyzing the head and the tail. We got its info. They are all integers and one float, which was an ST slope. We got the description of it, the count, the mean, STD, the 25% percentile, the percentiles and the maximums. So under the visualizations, we had a bar chart. This this was plotting the number of people, the age range in which different people fall in. We have a bar plot of sex. This shows the number of people and the sex variation of people in the data set, how many people were male and how many were female. In this sense, we have 1 and 0. We have a box plot of resting blood pressure. Resting blood pressure, we have the scatter plot that was visualizing the maximum heart rate with the age range of people in the data set. We have a pair plot variable. We have a violin plot cholesterol. This was the cholesterol with the age and the frequency. We have a correlation. This was showing the correlation of the different features with the output and all with each other. So we have a pie chart. This shows the chest pain type, whereby 52% were feeling a chest pain of 4, and others, as we can see. And when I go straight to the code, as I said, we have very many models. So I will not. The first one, this is the ANN model with an accuracy of 90.63. Then we went down to its confusion matrix, as we can see here, that it has the true positives of 94 and then true negatives of 60. We went to the GCN model. This GCN model had 2 layers, and its input were its input were the adjacent matrix and the the features, and its output was the prediction. And we did a line regression model. We did as you can see, we did a KNN. We implemented a KNN model, and the accuracy was a 71%. A naive-based model, a support vector model, and we also carried out other models. As we can see, the rest will be talked about in the report in full details. Thank you very much. Okay.
Hello, I'm Namtustiana, and I'm going to take you through the deployment. And here, this is just, we are trying to dump the model into a Pico file. And these are the attributes or the features that the user will input to make their prediction through the HTML file. So this is the interface of the deployed model, and it's showing the different fields where the user has to input the attributes. We use a render to deploy the model, and this is the deployed model here. So this keeps it puts the model out there for the user to use, and to keep tracking of the model, we use the ML flow. And then after the deployment, we used Grafana also to monitor the different times that the model is being used and the different actions that are going on. We used Grafana. And also, I'll not talk much about that. The different models that we came up with, as my colleagues have already talked about. So this is the tabulation, and these are the visualizations that I've already talked about. And yeah,